Thank you for joining us today. My name is Brett Philp. I'm one of the technical directors here at Densify. This is a Densify webcast on the topic of automated optimization. We'll step out of PowerPoint about halfway through the session and show some live optimization using Terraform. It's a pretty cool demo we've got to show you today. The session is being recorded and will be made available after the for replay if you like. And also in the GoToMeeting interface, there is a zoom in, zoom out control. Some people find that maybe they don't have the right resolution going, but you can use that to kind of see more of the screen or less of the screen as appropriate. So feel free to adjust. We've got 30 minutes today with my colleague Joe Pereira from our pre-sales team. He'll take us through the content. I'll be watching the chat window for any questions, so feel free to drop those in there. And then we'll get those addressed toward the end of the session. So with that, Joel, what's on the agenda today?
Awesome. Thank you, Brett. Yeah, so today we're going to be having a demo of using Terraform to automate our Kubernetes deployments and really optimize them. Excuse me. So we'll get started here with the presentation. All right, so I'd like to set up a little bit here in PowerPoint. We're going to keep it, like you mentioned, Brett, half and half, roughly. So in PowerPoint, let's kind of set up our, let's call it our environment or our overview here. So if we've got a typical Kubernetes environment, it's going to be, and let's focus in on, let's say, a Kubernetes cluster, right? We've got EC2 nodes. Let's say it's in Amazon. Really, it's not limited to that. It can be anywhere. It can be Azure, GCP, on-prem. You can use any kind of deployment infrastructure that you have in your organization. But in essence, we've got our little Kubernetes demo environment here, which I'll walk you through. We've got some images loaded. And what I want to focus on today is looking at optimizing our container resources. Okay, so these images get loaded. They're running all the time. Very tricky to go in and optimize them. And specifically, I want to look at these requests and limits. All right, so from a CPU and memory standpoint, these requests and limits, you can think of them as, if you're not already aware, kind of min and max values for running our Kubernetes containers. All right, and at the end of the day, these are what get executed and run in our environment, and they end up translating to hosting costs, but they're very tricky to get right, because we have so many of these things running out there. These are sized typically by the app owners, developers, using best practices out there, and depending on the application. In this case, if we look at our little image here, WordPress, typical one out there, it's very tricky to right size this, right? Not every WordPress out there is going to run with the same settings as all the other ones. Like, for example, and this is the same level of complexity as me, if I put on my developer hat, if I had to figure out how much CPU and memory PowerPoint needed to run, I would have no idea. So I'd probably edge on the, let's make it a little bit higher. Let's give it a little bit more resources. And this is what we see out there, is things are typically a little oversized to reduce any issues that we might have. But not getting these right can create some major problems, specifically around costs. Excuse me, but there's also performance related issues out there. For today, we're going to look at specifically the costing or the oversized aspect. All right, so this is what we typically see out there in a cluster. We took a screenshot of this from a customer. So we can see CPU reservation, right? This is our min, how much CPU we're actually using or assigned in the cluster. But we can actually see the utilization is much, much lower. And the difference here is that this is unused capacity, but this is reserved. It's locked down to these containers, whether they're using them or not. And so we see a lot of waste. And so when we're talking about Kubernetes optimization, this is one of the big factors that we're looking at, is reducing the stranded capacity, because this directly translates to higher costs. Do I really need a cluster of 4 or 5 or 50 nodes running out there? That's 50, let's say, EC2 instances running out there. Do we need all that if our actual utilization is much, much lower? You can see under 10%, but our reservation's at 70, 80. So what we what we like to say here in Densify is let's optimize this, right? So the way we go about this, starting with the basics, plugging it in, analyzing the actual containers, all of the containers running, and getting the recommendations, understanding their utilization, understanding their patterns. We do this automatically. Then we can start right-sizing these resources, right? The requests and limits, we can start right-sizing. Typically lowering, sometimes also giving more resources. We find that there's usually a small percentage of containers that may not be running optimally, and they may be undersized, so they're starving for resources. So we'll notice down here, the little Tetris blocks, they got right-sized, right? So now we've reduced and optimized the sizing of these containers. Then we can look at optimizing the nodes, optimizing the actual resources we end up paying for at the end of the day. So instead of, in this case, three nodes in our tiny little cluster, maybe we only need 2. And beyond that, maybe we can start optimizing some of these node groups further, right? Maybe we don't need a general purpose M6, 16x large. Maybe we can optimize to a C6, right? Make it more compute optimized or memory optimized, depending on your specific workloads. This is what Densify does, is optimizing at the container level as well as at the node level, right? And I'll show you that in my demo. So here I've logged in, and we are going to focus in. I've removed all the other containers. I wanted to focus in on this one. Call it Den Web, just a little web server. But this one was, and we actually took this from a typical example that we saw at another client, and just a little Nginx web server, very small. But you can see the CPU requests and limits are actually set quite high, and I'll zoom in on that for you. All right, so Densify's detected that it's actually set at 2,000 millicores, and to kind of break it down, that's like giving this web server literally 2 cores. So 2,000 equals 2 CPU cores, and that's locked out. So this isn't like the VMware days where you got overcommit and you can just, hey, it's fine, I can give a VM, for 8 CPUs. If it doesn't use it, it's fine, it'll overcommit and use it for the other VMs. That doesn't happen here with Kubernetes and with the scheduler. It's actually locking it out. So if CPU requests are set, in this case, to 2,000, 2 full CPUs, but you can see the actual utilization is under a half CPU. So do we really need all that? Not really. And that's not just the last, what we're looking at here is not just the last 24-hour period. This is over the last 3 months, if I recall, for this case. It's all configurable in the policy, but that's not the focus of today. But I can see in this example, well oversized, it's costing us a lot of money at the end of the day. I do want to take a step back just for a second and mention that, yes, this might not seem like a lot, like we're talking about a container, maybe it's running here or there, but these costs add up at the end of the day, right? We spawn 20 of these, especially over the several days. We're collecting all of that data, but it's also inflating the amount of space that we're using and consuming on the nodes. And that's what adds up to the costs. So this is what we're going to optimize. This is our example that we're going to optimize today. And I'll show you that shortly. And the recommendation we got here is, hey, based on the workload, we should tweak these settings. And I'll be doing that shortly. And the CPU request should be around 590, and you can see the limit at 1 CPU. So a little bit more reasonable, based entirely on the utilization for this container. All right. So we're going to do that in a moment. Let's keep going. This is my last slide, I promise. Then I'm going to dive in to the demo, and we're going to right-size that little web server that's taking up too much of my resources, too many. All right, so I just wanted to kind of take one last slide here and just provide a high-level overview of how this can work out there, maybe in your infrastructure or in other infrastructure. So kind of looking at it from an architecture standpoint, we've got our hybrid infrastructure, whether you're using any of the CSPs out there, you've got on-prem, you've got your Kubernetes environments, whether it's OpenShift or things like Tanzu or others like Rancher, you've got it running out there. In our case, we've got Densify plugged in to each of these, where we've got optimization recommendations, and today we're going to implement one of them. But besides just plugging it in and implementing, this is exactly where I want to mention that it is a bit of a crawl, walk, run approach. We don't always recommend plugging it in, taking a recommendation, and automating everything, hitting the big red easy button. from an automation standpoint. There is a bit of a learning curve. So crawling, walking, running, taking the recommendation, building the trust from that standpoint. And we have a whole process for that. That, though, is not the purpose of today's session. Today, we're already walking and we want to run. So if we've got that, let's continue on. So we want to integrate with an ITSM tool set. If you've got change management in your organization, which of course everyone does, certain ones like Jira, ServiceNow, or any ones, we can integrate with that. Then it follows your change management process. So before changes get implemented, you've got that control system in place. Maybe it's GitOps, whatever it is. You can apply it there. You want to store those recommendations somewhere locally that are accessible within your environment, within your CI/CD pipeline. Because you don't want to be making deployments and have to make an outward call that is beyond your control, right? So you want to take these recommendations, store them in something like a parameter repository. But that's optional. You can store it really wherever. In today's session, I've just stored it in a text file, which you'll see shortly. And then you've got some integration with your pipeline, your tool chains. You got source control, you got the CI component, which is pushing it out, as well as, in this case, we're using IAC or Terraform for infrastructure as code. And that's the example that I'm going to use today. And this is kind of a typical architecture slide. It's going to be different for your organization, but hopefully some of these logos are similar to what you guys may be using. So in our case, we're going to focus in on Terraform, and we're going to deploy taking the recommendations that way. So without further ado, we are going to step out of PowerPoint and let's set the stage. So now I might put on my engineering / developer hat on. So let's look at our Kubernetes environment. And I've got a small little demo environment here. So I'm using Lens to give me insight into my little small cluster. This is my Kubernetes cluster. And we're going to focus on that den web container. There it is. Okay, so we've got it running here. It's running in my cluster. Now I'm going to put on my developer hat and say, okay, so we've already had the discussion to say, yes, okay, we need to reduce the footprint of this container. And I can prove it to you here if I look at the manifest or the schema here. So we're going to go requests, right? 2 full CPUs that this container is taking. So we want to reduce that. Are we going to change it here and reapply it? No, that's not the right place. So what we're going to do is go into the source control, source code, maybe Git, and have a developer make the change there. And that's why I'm putting on my developer hat. All right, so let's do that live here. So I've put it here locally on my desktop so you can see exactly what I'm doing. So got my little folder here, I've got Terraform executable here, den web. This is the definition for that running, opened up here, for this container. Just a small little Kubernetes deployment. I'm going to full screen this. Hopefully I've zoomed in here, so hopefully you guys can see this. And we've got our little deployment. It's just Nginx running one replica. And if I scroll down here, you can see these settings are statically defined in here, right? So as a developer, someone has gone in. I'm going to put my hand up. Oops. And we saw that they worked in development, and we use them. If it ain't broke, why fix it? Now I can go in here and take that recommendation and say, yeah, let's just put it in here, right? Great, we can do that, and we can redeploy it, and that is optimization. But the focus of today is having continuous optimization. So that's not what we are going to do. So what I'm going to do is kick off my little pipeline here, CI/CD pipeline. And all we're doing, this is just for demo purposes. This will be very different. Maybe you guys are using Jenkins or Arlo or other ones out there. But all I'm doing here is just applying, running Terraform with apply with auto approve, which is to say we're going to take this definition and Terraform is going to look at it and apply it if there's any changes. So if I go in here and let's say, make a change to say, hey, this is Kubernetes, I want 2 of these replicas to run, right? So within a few moments here, apologies for any delay. This is what happens with running software. Sometimes there's a little delay, but here I've as a developer, I've gone in, I've changed it to say, I want 2 of these pods running, right? So it's going to do that. You can see Terraform detected it within a few seconds and it's redeploying. You're probably not going to run this every 3 seconds like I am. Probably going to do it maybe every week, every quarter, whatever the change frequency is, or maybe on a change as well when you're deploying updates. But for the purposes of the demo today, I don't want to make you guys wait. And I'm sure you guys don't need to see me take in code, commit it, etc. So we're going to skip those steps. So I'm just making live changes, and it's going to happen live here in my Kubernetes environment. All right, so I'm going to change that back. I only really need one of those because that is taking up 2 CPUs. I don't need to blow past my limit on my nodes, which is another risk, right, when we're oversized. So how do we optimize this? All right, so first step is we need to automate getting these recommendations somewhere. Now, since I've got the recommendations in Densify, maybe we've got it in the change request ticket, but we're going to use an API, of course, to automate this. So I'm going to pull up Postman. It's just a tool you can use to, as I'm sure many of you are aware, you can plug into any kind of API. In this case, we're REST-based, JSON-based, and I've already downloaded and loaded the Densify API collection, which makes it easy to make these calls. I don't have to look up any documentation, load it, and I've already plugged in my configuration. So we can just go, I'm going to use the API to say, okay, let's log in, get me this token. There we go. So now I'm logged in. Now I can make calls, no problem, because I'm authenticated and authorized. So I can pull in recommendations for public cloud or containers, of which I'm going to focus on Kubernetes today. So I want to make sure you guys can read this here. There we go. Get analysis recommendations, and we're going to run this live. So we're not demoing PowerPoint here. So hopefully nothing breaks either. All right, so I've pulled in the recommendations, and it's a fairly long list. So I'm going to just search it here, DenWeb. So you can see I've pulled it in. I've got it here, and I can scroll down to I can see current CPU memory limits and requests, as well as the recommended ones. And I think the one that I want is current CPU limit is 2, so we're taking up 2 full CPUs, and the recommended CPU request is somewhere in this list, recommended CPU request, 590. All right, so now I've plugged in. I can use maybe a Python script to pull this in, store it locally. I've already done that. I'm gonna bore you guys with that. So let's just see it here. So in this folder, I've got Densify recommendations. All right, so we'll just load it up here. So I've already got it. One little difference is that our API is JSON based, but Terraform doesn't use JSON. It uses its own variables and parameter syntax, or format rather. You can do the conversion yourself, or you can just pull it in using our specific API for Terraform, which would use a special header, of course, to say, hey, give it to me in Terraform format. So we've got that here, same data. I've just copied it and put it in the file. All right, I'm going to maximize this so you can see. And current CPU, that's limit current CPU request, and the recommended CPU request 590. Great. Okay, so now I've got this file here. Now, how do I apply it? Apologies for any background noise. Okay, so I'm going to put on my developer hat, and we've got our Kubernetes deployment, DenWeb. I have already copied and pasted here where we've got a Terraform module I've already loaded. It is incorporating, I've passed in my organization's Densify recommendations that we've analyzed, as well as some fallbacks. And we're saying, hey, within those recommendations, look for this one. And instead of using these static values, what we're going to do is say, hey, don't use those. Mr. Developer, use these. Use the values that we get that are analyzed from Densify. So we're going to take CPU request, for example. And we can do this for limits as well. You see here, if I scroll down, so I'm just going to do that. Okay, let me set up my stage here so you can see DenWeb is still running. I have not saved this just yet. My CI/CD pipeline is still running here. If I hit save within a few moments here, Terraform is going to run because it's running every 3 seconds. It's going to detect the changes that I've made to my source control. In this case, just a file running locally. But now it's going to take this and it's going to do its magic to pull in the recommendations that I've pulled via the API. All right, let's give it a couple of seconds here. And now it's reading. And I have set the CPU requests, sorry, CPU and memory requests and CPU and memory limits. Boom, okay. So now I'm gonna pause here on my little CI/CD pipeline, and you can see the changes. You can see in the background, it's killed off the old container and it's redeployed it using the new values. You can see them there, right? CPU requests from 2 or 2000 to 590. And if I want proof to make sure that you guys believe me here and that I don't have a magic gremlin in the background deploying it for me, I can look at this container, hit edit, show me the manifest or the definition, requests here, so 590. Now, what makes this cool is not that, we've got Kubernetes and we're deploying this magically here. It's that now as a developer, I no longer have to worry about picking and, scratching my head about, well, how much resources do I have to give this web server? Or to take it a different approach or a different analogy, if I'm running PowerPoint, how much CPU and memory does PowerPoint need, right? I don't have to worry about that. Now it's always continually optimized here with Densify. So if your workload changes, right, for this web server, let's say there's different user load in the future, maybe different features, maybe we have lots more users out there, maybe it needs more resources. Densify is going to detect that. It's going to automatically analyze that on a daily, and the recommendations may change so that a month from now, 2 months from now, you've got your pipeline already running, and you'll just see that it just gets updated, just like this. So it's already detected, hey, okay, Densify's got a new recommendation. We need to give it a little bit more resources, or maybe less resources. It's going to detect that, and as a developer, I no longer have to worry about optimizing and making sure that we're right-sizing these containers. And so that is continuous optimization. That way, we're striving to get in that balance of performance and cost savings, right? Make sure that we're running optimally, which is a very tricky challenge, and that's why we really push for automating this, because it's way too difficult to do. There's just not enough time for any team to do this when you're talking at scale, right, of thousands and tens of thousands of containers. So that is my demo. So I will come back here to PowerPoint. There we go, and open up the floor for any questions that we may have from the audience.
Cool, thanks, Joel. Always good when the demo gods are on your side. That was a great example of calling the API, getting the recommendation, and then pushing it out onto the environment through, in this case, Terraform. And I guess if a customer wanted to do this with a different technology, we were asking earlier in the call about different IAC tools that customers might use. It would just be a matter of using those tools to call the same API effectively to get the reco and then apply it.
That's right. Yeah.
What are some examples of types of recommendations? Because at the beginning you talked about like the request and the limit as two different types of recommendations that Densify is producing, and there would be each of those would be available for both CPU and memory. So what's an example of a type of recommendation that you would look to put through automation versus maybe one you wouldn't?
Oh, so I will say this is very dependent on the organization, what their priorities are, and we always advocate a crawl, walk, run approach. But if we're talking more on the walking and running aspect, if it was up to me, I would optimize first anything that's undersized. So you would see upsize recommendations to say, hey, these containers, they're starved for resources. Maybe they're having performance issues, and we definitely want to curb that. As well as it also helps to build trust with the app owners, because I have yet to see an app owner that says, no, I don't need more resources. Typically, they're like, yes, I need to keep all the resources. So you'll see upsize recommendations. So I like to start with those. And then there's also unspecified, which I might want to look at beyond just the very large, the very large oversized ones. You maybe want to reduce that, but then the unspecified are also going to give us issues in Kubernetes. So kind of looking at those.
Okay.
Hopefully that answers the question.
Yeah. How can customers try this themselves?
Cool. So yes, great question. And I'm gonna open up my little browser here. Here we go. So you can contact us for anything Densify related, but from a module aspect, what I showed today was the Terraform module that we have. So you can access it online. You can download it, integrate it. We've got plenty of scripts. We can help you out with that. Customer examples. It is open source, so you can have a look at our GitHub page, and you can download it yourself, look at the code. Happy to help with that as well if you have any questions beyond the 30 minutes or so that I have of time today. But yeah, you can definitely have access to all of this online. And I believe we'll share out the links in the
Yeah,
chat.
I see the links in the chat there, both for the Terraform module directly as well as our GitHub page. So yeah,
Awesome.
great place to go and check it out. I'll also mention that I know that for the API, the things that you were showing in Postman, there is a collection that's in our documentation, which we've always had really good feedback on. If people want to play with the API and Densify, that's a great way to get started.
That's right.
One more for you, Joel, if you don't mind. What would be different about doing this, say, in public cloud, like say doing it against, I don't know, an EKS cluster on AWS versus doing it maybe on a OpenShift cluster on VMware internally?
Interesting. I would say from a technical level, there's probably not that much difference, right? You still have to do the data collection, analyze, right? Get the recommendations, integrate them. So that part doesn't really change, especially if it's anything Kubernetes based, like you mentioned, OpenShift, wherever it's running, it's still Kubernetes. So we'd still collect the same way. The difference becomes twofold. One, how you apply the changes, right? There's going to be different API calls, maybe different tools that you're using, as well as the difference might be more on the strategy aspect, or what do we need to optimize depending on your organization. So if you're looking at cloud costs online, so like in AKS or Azure or EKS in AWS, you want to reduce your footprint because that's how you start saving costs. So you want to optimize maybe some of the big ones to hopefully reduce the cost there. If you're looking on-prem, you kind of have sunk costs, right? You're looking at CapEx versus OpEx, but you want to also take advantage and fit as many more containers into your existing infrastructure. So scaling, it might be trickier on-prem to scale and add more nodes, but you definitely need to optimize and raise the utilization ratio within your infrastructure. So not
Yeah,
too big of a difference.
it's interesting because the benefit is slightly different depending on where you are, right? There's a monthly cost you're avoiding by
Exactly.
spinning out that next node if you're in cloud, but on-prem, as you say, it's a sunk cost. So really it's cost avoidance. So
Cost avoidance.
trying not to have capital cost to buy another host, yet another
Exactly.
host.
Pushing
When
it
there's
out, yeah.
shortages for available hardware, right? So
Exactly.
cool. Okay. I don't see any more questions here, so we'll just slip back to the PowerPoints there for a sec. And I just wanted to share that the great news is that we've introduced an offering with the help of Intel. Customers can take advantage of to get familiar with the Densify offering and learn about potentially how big the opportunity is in your environment, and then start looking at how you could actually plumb the recommendations for optimization into your automation pipelines that you use at your company. The program's called Intel Cloud Optimizer, or ICO as we like to refer to it. It is sponsored use of Densify for a 1-year period from Intel. And there's also assistance provided from the Intel team to help determine the most optimal state for your infrastructure, given all the awesome technology that Intel's bringing to market. It's a great no risk way to try it out. Again, see what the size of the opportunity is for your company and your deployment of cloud or on-prem infrastructure. And with that, I think the next chart is going to show us our next upcoming webinar. So one of my colleagues is going to be doing a session on what we affectionately call the last mile of optimization, June 23rd. So go ahead and sign up for that. There should be a QR code here that you can link to, or you can find it on our events page on the website. With that, I want to thank everyone for joining today. And if you pick up the recording and have any questions, feel free to reply back to us and we'll help you out. Otherwise, Joel, thanks for doing this so much, and have a great day, everyone.
Thank you.